Okay, in this question, we are going to look at number 6, figure out, so a plane is flying in still air. It takes 15 minutes longer to fly 1,260 miles into the wind than it takes to fly 1,320 miles with the wind. Find the speed of the wind. All right, so to give ourselves more room, I want to do this real quick. Sorry, you should fast forward if you're watching the video. Okay, man. Cool. So when we do these related rate problems, distance, rate, and time, I like to set up a little table like this. So I got distance, rate, time. So I got 3 columns for that. And then my rows go whatever 2 variables or 2 situations that we have. So we have a plane flying into the wind and then a plane flying with the wind. So it says that the plane is flying 800 miles per hour in still air. So let's say this is the plane going 800 miles an hour in still air. Then you have a wind behind it. Let's say it's 50 miles an hour, right? Pushing it. Then the plane will actually be traveling 850 miles an hour if you're looking at it from the ground, or if you're in the plane, that's how fast you're traveling. But the motor is only going as fast to make it move 800 miles an hour. You just have this behind it. So imagine that you're on a scooter and you have some momentum going already and you're traveling at a rate and someone gets behind you and pushes you, like you're going to go even faster, but it's going to take less for them to push you because you're already moving forward. So when we do these tables, you're going to have like 3 columns, and like one column will usually be given to you completely. Then the other 2, you'll have to use the information to relate the variables, one above the other. And it doesn't have to be like any of distance, rate, or time could be given. It could be either of the 3. So it says it's flying 800 miles an hour in still air. It takes 15 minutes longer to fly 1,260 miles into the wind than it takes to fly 1,320 miles with the wind. So the 2 things we're going to relate here is flying into the wind versus flying with the wind. So into the wind, with the wind. So into the wind, you're going to be going slower. With the wind, it'll be faster. Okay. It says you're flying 1,260 miles into the wind. So 1,260. So if the plane is traveling 800 miles an hour, that's going to be our rate, but you also have to consider that you're going into the wind. So I'm going to subtract W because the wind is slowing you down. Now it says it takes 15 minutes longer to fly into the wind than it does with the wind. So I'm going to make the time with the wind T and make this T minus 15 minutes. Now there's something else that I haven't mentioned yet that you have to be careful of, and that's the units. So when they give you the rate, it'll tell you both units, or at least the units that I suggest you work in. If they give you a rate in 800 miles per hour, all right, I like to make note of that right here, because then that tells me that time has to be in hours and distance has to be in miles. So you want to stay consistent. If your rate's in miles per hour, you don't want your time in minutes. If your distance is in feet, you don't want your rate in miles per hour. So just it doesn't matter what unit you use, you just got to be consistent. So I'm going to do T minus 1/4 because that is 15 minutes as an hour. All right, 1/4 of an hour is 15 minutes, 15 over 60. So now, so it takes 15 minutes longer to fly into the wind than it takes to fly a different distance, 1,320 miles, with the wind. So now your rate is going to be 800 plus W because we're going with the wind. Find the speed of the wind, so we have to find W. All right, so that's the hard part. Solving this equation should be easy because if you have a TI-inspired CAS, it's going to do it all for you. And if I gave you a question like this, you would definitely have the ability to use a calculator. Right? Modeling is all about taking math to a real world situation, figuring out, a method of solving it. To me, it was this table, and now we have equations to represent the information. But the solving the equations part all can be done with the calculator. All right, so now we're going to type this in the calculator. So I might need some reminders of the little print screen so I don't forget. So I have to type this in the calculator. So let's see, let me put this here. So now I'm going to open up my TI-inspired CAS. It's going to take a second. I should have had this open earlier. My apologies. And if you have a TI Inspire non-cast, you will not be able to do this. You would have to solve it. You could solve it with the calculator either by graphing or substitution. But let me show you how much easier it is when you have the cast. Okay, so I'm going to go to the home screen. So home, open up a new document. We want to add a calculator. All right, so we're going to solve a system of equations. So go menu, algebra, and if you had a non-cast, you would have the option for solve system of linear equations, which is good. But these aren't linear equations. These are regular non-linear equations. So we would have to use this option, solve system of equations. And that option is only available with the cast. So we have two equations. We have the variables W and T. You could leave X and Y if you want, but we might as well use W and T. And I'm just going to type in the equations exactly how they look. 1260 equals parentheses 800 minus W times T minus 1/4. And then 1320 is equal to parentheses 800 plus W times T. And hit enter. And we get a really complicated answer because it's exact. And that's okay. If we arrow over, let's see, we can hit that. We can copy and paste it and hit Control Enter, and it will approximate it for us. But I feel like something isn't right here. With the wind plus T, I did this earlier and it worked fine. Did I type something in wrong? I did this earlier, like last period, and it came out fine. I did the same way. So the wind is 43. The wind should be about positive 80. So we're going to go slower. It takes less time. Oh, 15 minutes longer. Okay, so I see my mistake. I was too worried about the units. This should be T plus 1/4 because it's the time it takes to go into the wind. So that top row takes longer because it makes sense. Even though you're traveling a shorter distance, the wind's going to slow you down. So now I hit enter. And now we have both points. So we have one point where time is negative and the wind speed is negative 10,000. All right, so we're going to ignore that answer because for the domain for wind speed, it wouldn't make sense to have a negative speed. But the second answer is in our domain. P is equal to 3/2, which makes sense because if time is the distance, the time that you're traveling in the plane, you want that to be greater than or equal to 0. And when the time is 1.5 hours, 3/2, the wind speed is 80. All right, so that's our final answer, 80 miles per hour for the wind speed.